McDonald. I am with the MPCA, and Curtin and I are going to be presenting some information on the MPCA Lab Certification Program, which is brand new this year. It applies specifically to wastewater and water quality labs that previously had certification under the Minnesota Department of Health. How many people in this room actually have labs at their facility? Okay, so a very small number. So this is really just an overview of what's going on in case you're hearing rumors. This may have an impact on you if you send your samples to another facility, another municipal facility for testing and that sort of thing. But this will be just a real brief overview, and then Kay's part of the presentation will get to some real meat that will apply to everybody. Forward. Okay. Okay, so a little history of what we're doing and why we're doing it. The history of lab certification in Minnesota is that prior to the mid-1990s, all of the inspections, all of the lab inspections for the municipal facilities, for the wastewater plants, were done through the Minnesota Pollution Control Agency directly. But the inspectors for the PCA weren't necessarily trained chemists, and a lot of them weren't really comfortable reviewing chemistry methods and that sort of thing. And the Minnesota Department of Health already had a lab certification program for their drinking water labs, and so it seemed like a good fit to partner for the certification program and allow the Department of Health to take over certification for not only the drinking water facilities, but for wastewater, industrial, and commercial environmental lab data. And so that went along for quite a while. Okay. So what are we doing now? Well, the Environmental Data Quality Unit, of which I am a member, is developing a lab certification program that applies specifically to NPDES permitted facilities and a small number of water quality labs from universities and counties and that sort of thing that do work specifically for the PCA. So it's only labs that have NPDES permits that can do work for under our program, and this does not apply to commercial labs. Why are we doing it? Well, in 2009, the Department of Health adopted the NELAC standards, which is a national standard to which 14 states in the country belong. And most of those states do have a two-tiered program. They have one set of certification standards for the commercial labs that do work for big clients, and then they have another set of standards for the smaller wastewater facilities, and so they worked it out that way. Minnesota chose not to go that way. The Department of Health chose not to do that two-tiered system. So then what we ended up with was a standard that just was not a real good fit for the small labs. Their major complaints were that this new program was too costly, had too much paperwork involved, and too many performance test samples that, again, add to the cost. So in 2011, the Coalition of Greater Minnesota Cities had put together legislation to get the Department of Health to do a two-tiered system, which sort of happened and sort of didn't. So we were losing, the crux of it is that we were losing a lot of the wastewater labs in the state, and over about the last 4 years, we were able to show that we had lost about 12 facilities, and I know that there had been a gradual trickle prior to that, and so the Pollution Control Agency, which does the permitting for this program, was real concerned about this and really wanted to keep the labs that we have in place. So what are we trying to do with this? We're trying to create a program that's specifically geared towards the small labs. We formed a steering committee back last fall that has members that represent both large and small facilities. We have industrial people, we have data users on our committee. We think it's a real well-rounded group. And our goal is to retain the elements of a quality assurance program that will keep good quality data. So we want to keep the good parts that help look at data and make sure that the labs are producing good data, but we want to reduce the unnecessary paperwork, the things that just don't apply to the small facilities. And we want to lower costs for people because we want you to keep your labs. We want the labs to stay in business. We want to be responsive so that when you send emails, phone calls, whatever, someone gets back to you within a day or two so that there's a good response there. And we want to be able to provide training for people. So real hands-on, specific, practical training. So this is just a quick shot of the diversity of people that have agreed to be on our steering committee. So you can see it's quite a diverse group. So who can join the MPCA lab certification program for 2013? At this point, starting January 1st, the people that could join were labs that already had accreditation through the Department of Health in 2012. That way we knew that they had standard operating procedures in place, they had quality manuals, they were already basically familiar with the types of things that we were going to ask of them. These are municipal, government, and industrial labs who are NPDES permit holders. Now there's been a little confusion with this because I know some of these larger facilities do work for other municipalities. That's fine, they can continue to do that. So if you're a smaller city and you send your work to a larger city for testing, that's fine, they can do that. We are not considering that commercial because you both have permits. So as long as there's a permit involved, that works out. And it does require all sorts of testing that would apply to permits. So if you have a lab and you are testing waste producers upstream from you that contribute to your load, that's fine. Or if you are an industrial facility who is doing work for other plants within your system, that's fine too. All of that is considered non-commercial. So the challenges that we've been facing since we kind of got handed this program right after Labor Day, and it's been sort of on the fly, is that we are creating a program completely from scratch at this point. So we have at least been able to identify the facilities that we wanted to be involved and have gotten a really good response from them. We are struggling with the Pollution Control Agency is a real big company, basically, and so struggling to get this information out to inspectors and permit writers and other programs within the agency so that they know what's going on and that there is some wording that can change on future permits coming up to allow for this program, not just the Department of Health. Initially for this year, we don't have any specific funding. We are not charging the labs anything to be part of our program for this year because we're working on a funding mechanism but don't have that in place yet. And we don't have any staff dedicated to this program. And so there are a few of us that are doing the best we can to put in time and to be responsive to people, but staffing will come in the future. So where we are today, we had put out a call to the labs that we had identified as being able to join our program last fall. and they've all submitted registration forms to us telling us what types of testing they wanted to be certified for, and have supplied us with their quality assurance documents to support that. So we've got that in place. We're working on getting a database in place to track all of that. Once we get all that in place, we will be issuing certificates to labs. I know that that's something that they're feeling a little uncomfortable with at this point, as they don't have something nice to hang on their wall, but that's coming. That will be coming. We do have a draft policy that was submitted to our steering committee a couple of months ago. That's going to be changing. It's going to be pared down and simplified as this goes along. At this point, we do have language that has been submitted to the legislature and is working its way through the legislature to make this program official and allow us to be able to collect funds in 2014 to be able to run the program. Our assistant commissioner has taken this legislation to the legislature, and so far it's gotten a real good reception because we are trying to make government more efficient and streamline things. We'll be bringing in now the lab certification into the same agency where the permitting is done and the inspections are done, and so our net goal is to increase the efficiency within our agency. So what we're working on for the rest of 2013 will be to understand where labs need training and assistance. That's an awful lot of what I've been doing for the last 4 or 5 months, is just answering phone calls and emails from people where they have questions about what methods can I be doing. They've had questions that have been hanging out there in the past under prior certification, and we're working with vendors and our permit writers and our enforcement people so that we can communicate effectively. We want you guys to be able to do things in the most streamlined and efficient way possible. And so we'll also be working with our steering committee and the MWOA lab committee to address future training and quality control, quality assurance issues. We hope to be able to hire someone to be dedicated to this program full-time in the late spring, early summer. Right now we have a certification website dedicated to this program specifically. I know that's kind of a funky connection that doesn't really make much sense, but if you are interested in more information, if you go on the MPCA main site and up in the little search bar, just type in lab registration. It's the first search that will come up, and it will be the NPDES lab registration program. Here's a list of contact information. I don't expect people to memorize this, but there are several people that can field questions about this program. My supervisor, who some of you may have run into over the years, Luke Charpentier, is, as of Friday, will be in Afghanistan for his 4th tour of duty, so he's out temporarily, and Bill Scruton will be supervising the unit, and he's been a long time both public employee through the PCA and the Department of Health, and has a lot of private sector experience, so he's a very knowledgeable person, and Kay and I are both available to field questions, as well as Matt Linden, and a lot of you know Roger Fisher as the DMR QA coordinator for the state. So there's several people that you can contact. Does anyone have any questions? Okay, I will turn things over to Kay. Oh, sorry. Yes.
Good question. PT samples, right now, I've kept my schedule from you're working with NELAC, I'm getting set to do that.
Mhm.
When I have them, who do I submit them to? I mean, before we had Roger Fisher and then also the Department of Health, I put them through, with the vendor I'm working with. Are you guys listed with vendors, so those results will then come to you?
It's up to the facility to inform the PT provider who they want the results sent to. So we can't tell them.
I understand that, but are the providers aware of the fact that you're doing this?
It doesn't matter. Whoever you tell them to send the results to, they'll send them to.
Okay.
So continue to send any of your results for our program to Roger Fisher. And so whether that's DMR QA study results or anything that you do that's outside of that, we're going to have Roger coordinate everything so that you've got one contact for PT stuff. And I've got a series of updates that I'm planning to post to the website within the next couple weeks. And we'll send out an email update to the participating labs when that happens. But that's one of the big questions is, how many PTs do I need to do and who do I send the results to? And so the answer for right now is we're cutting back to 1 PT per year rather than 2, and everything will be sent to Roger, and that will be updated on the website.
Is that for everything? Are they going to use the water too, this water, or is it always used? It does not?
No, we're just wastewater.
Just wastewater.
Yes, yeah, this program does not include drinking water. It is only wastewater and water quality work that is done through special studies. But yeah, the Department of Health will continue to be the drinking water certification body.
Any other questions for Sandy?
Can you hear me? Some of you, I gotta get out of the light here. Some of you might know me. I am not in the same unit as Sandy. I'm a wastewater trainer. I'm just an old wastewater operator that always, wherever I worked, I seem to end up in the lab. Could be my lack of mechanical skills or the jet machine incident or something like that. But I always ended up in labs, and I was a lab director, and then I worked for Rural Water as a consultant. About the same time that Wisconsin was changing their certification regulations. So I got together with their DNR people and their state level hygiene, and we did just tons of wastewater training. And it was good training, it was great. NELAC reared its head a couple times over there, and we did not allow it to come into the state because we already had a really good program, and we didn't want the fees to go up. And we wanted to continue doing training. So that's kind of my history. I've been a consultant with engineering firms and now with the PCA. And since I'm kind of an old lab rat, I field a lot of the questions. And I don't know if you've heard the term consultancy, but in the Department of Health's defense, it's not just something they made up. It's been difficult for them to answer questions. There's a liability issue. If you have a problem and you were written up for it, they couldn't always tell you how to do it correctly because of NELAC consultancy issues. And I've got my own company where I work at any state but Minnesota right now. I'm working with a company from a big lab in Texas. And they were written up for a lot of things. They lost their certification. But I can't get out of the state people exactly what they're doing wrong and what they should be doing right because of this consultancy. And we were running into this. It was very frustrating. I wasn't allowed to tell people how to do things. Well, now we can. And I plan on doing all the training I could possibly find time for. And I know Sandy is doing a tremendous amount of work on this, and she's got another job to do. I've got another job to do. My boss isn't real amused by some of the time I'm spending at this, but I've been trying to do more on weekends. Okay. If you are, or you wish to be a certified lab, and I am understand if you are a little bitty pond system and you're doing everything, water, wastewater, dog catcher, skunk catcher, you name it, you know, you don't have time to do your lab work. It's easier and more economical for you to send those tests in. But as times change, a lot of the systems are changing over from ponds to activated sludge. And I'm always hoping that they get some type of a lab, at least for process control for activated sludge. They need to be paying a lot more attention than they did to a pond system. Then it's only maybe one more step up to get certified for solids or certified for some of the nutrient tests. So I'm thinking that maybe the landscape may change in the future. I watched it change in other states that I worked in. And I'm thinking, you know, in the next 20 years it probably will change here. If nothing else, you need to do some monitoring, depending on what your permit says. Okay, without quality control, you really don't know what you're doing. Quality control is just a little guarantee. And I always go back to the same old thing because it's emblazoned in my mind. I've been deposed a few times, a couple times, with environmental attorneys. These people know their stuff. And say that you have an industry that disagrees with you in that town. And you get deposed, and they've got an environmental attorney saying, well, how do you know your stuff is good? Well, you better have your I's dotted and your T's crossed. And that's what quality control and quality assurance and certification will do for you. You need to have a plan of some type. Quality control is what you do on a day-to-day basis. It's your blanks, it's your duplicates, but you need to have an overall plan. And we're going to try to help you with that. It's nothing mysterious. It's nothing that's going to be extremely time-consuming. I'm kind of the queen of plagiarizing. And since we put a lot of these materials together before in Wisconsin, we're borrowing some of them with their permission, and we're updating them. It's good to have this plan for a lot of reasons. For one thing, if you are seeing some things going wrong in your testing, you're going to be able to track it. You're going to know if the plant is upset or if it's just your testing that's not right. The plan does a lot of things for your system. There have been some new regulations put out. It's actually an update by the EPA, and they have 11 points, and it's really, to me, it wasn't anything that was too new. It's things that most people should be doing anyway. It points out some of the quality assurance procedures. There are procedures out where they don't really say exactly what you're supposed to be doing, and this just points it out. And we're going to be doing some training, starting with the MPCA conference. We only have an hour and a half to do training for that, but we're going to be doing some training in June and July through MWA. And my supervisor has allowed me to do some training and some on-site work with laboratories too, if anybody needs any assistance. Like I said before, quality control and quality assurance work together. We have the procedures and then you have the plan. And it's a lot like deer hunting. I got to show off. I have to show some of my pictures. I took one of my big one, my 18-pointer, but it didn't come out. It was too fuzzy. I couldn't put it on there. But I like to deer hunt. I like to bow hunt. And so say that you don't check that bow. You don't have the right kind of arrows. You don't practice. Are you going to be able to shoot a deer? Probably not. So there's a couple things that you're going to have to aim for. Say you're shooting at a target and you shoot 2 arrows. They don't hit the bullseye, but they do hit almost right on top of each other. That means you're precise. And there are certain things that you can do in your laboratory, like duplicates. You do the same sample twice. See how close they are to each other? That's how you determine precision. So when standard method says you got to determine precision, you do replicates, and we're going to help you with that. And accuracy. Accuracy is when you hit that bullseye, it goes right through the heart of that deer, right where you aim for. You do it 2 or 3 times, it's right on the mark. There are a lot of things that can prove that you're accurate. There's spikes, there's calibration blanks, there's laboratory control standards, there's your PT samples like Rich was just asking about. Those all prove that you are doing what you're supposed to do and you're doing it accurately. Some other examples for quality control are blanks, and you're probably doing this even if you're not certified, you should be. Calibration checks, demonstrations of capability, performance evaluation samples, your PE samples, and there's other things too that we'll do more training on, in-depth training. You'll have to have SOPs, just like you did for NELAB. But we're going to have a template, fill in the blank template, but you have to put down actually what you do, not what somebody else does for your SOPs. Your QA manual is just what you do for quality assurance, and you're going to have control limits for a lot of these quality control checks. And then control charts are optional, but some of the stuff that I'm putting together has automated control charts in it. And then you're going to have to do corrective actions. If you're way off base and you continue to be way off base, you've got to find out what's wrong, which is just natural. The good news for this is that we are going to supply, and I have the drafts with me. I want the steering team to look over some of these before we post them on the website. Like I said, I'm the queen of plagiarizing, and some of these have been plagiarized from former classes and from Wisconsin. And they are spreadsheets in Excel. Hopefully all of you have Excel on your computers. What you do is just put in your results. It does the calculations for you. If you want to do a spike, it can calculate the amount that you do. It will calculate your method detection limits. It's a group of a large group of spreadsheets in one workbook that we're going to be handing out later in the year at some of these MWA trainings. I am getting some CDs to burn these on. You don't have to buy them like you did for NELAB. You don't have to buy our policy. You don't have to buy the templates. We're also putting together templates for QA manual, for SOPs, things like that. More or less fill in the blanks. And like I said, I don't have a college degree. For some reason, I like statistics. Statistics stick in my mind, so I'm pretty good at teaching how to do some of this stuff. But you don't really have to know with these spreadsheets. You just put in your answers and it's going to tell you. It'll also tell you if they're good or bad. It'll throw out the outliers. It does pretty much everything for you. If you're not going to be certified or you're not a certified lab, there's still some things that our inspectors are probably going to want to check over. Sooner or later they're going to be looking at that kind of have to do with the laboratories. You probably already know this, but how many of you have really looked at your permit? Most of you probably, you're small towns. Pretty familiar with your permits, right? Well, that gives you a lot of details about how to sample, where you sample, what type of sample that you're going to take, etc. We do get calls about this occasionally, and we've had a pretty big staff turnover too. But the best way to find out in detail, if you don't understand your permit, is call your district office. And they can tell you who your permit writer is, who your compliance officer is. There's some new ones in the state. And they can answer those questions for you. One thing that you need to be aware of, and this goes back to those wonderful lawyers again and liability, is your chain of custody. That is a legal document. And I know some of you drop stuff off at a post office and it might sit overnight somewhere. But everybody that actually handles that sample is supposed to sign off on a chain of custody. And you need, or your laboratory needs to keep those on file somewhere. Because one of those depositions that I got called was a town that was trying to sue the engineering firm that I worked for, and they were saying that I tampered with the samples that I took. Well, I sealed the samples. I could prove that I didn't tamper with them. They were sealed, they were handled by me, they were handled by the UPS person, they were handled by the laboratory, no one else. And they watched me seal them. So if I wouldn't have used that chain of custody, I could have been in a lot more trouble. So it is actually for your protection. If anybody questions your results or questions any tampering or anything like that. The types of samples that you take are either grab or composite. How many people here have composite samplers? Oh, quite a few, okay. How many of them are set to time composite? You gotta change that. That's gotta be set to flow proportional. The older ones were still set to time. Hopefully they can change it. They need to hook it up to the flow meters electronically. So that flow meter will send a pulse back to it. And you can set it for like every 10,000 gallons, it takes a certain amount of sample. It's much more accurate. If you set it for time, say you're a really small system, you only take it once an hour, somebody could dump a lot of stuff within that hour and it wouldn't catch it. So flow proportional are much more effective. And they probably will be asking about that sooner or later. So keep that in mind. Thermometers, we get a lot of questions about what kind of thermometer should be in composite samplers. You need to have one that is at least checked. I don't think it's a regulation, but it needs to be checked against a good thermometer at this time. You can buy really cheap certified thermometers now. They just kind of stick, they're sticky, and they stick on the door of these things. You throw them away after a year or two. Otherwise, you can borrow a certified thermometer from somebody and check yours against it. But they do need to know that they're accurate thermometers. There were some that were kind of questionable over the years. Okay, going back to sampling. To grab samples, most people, is there a question?
Yeah, okay, I'm sorry.
That's okay, no. Go ahead.
The ones you buy, the thermometers you buy now, they used to come in with a 1-year certification.
Yeah.
I'm seeing them now coming in, they got a certified date when they were done. There is no expiration date. What is the statement used?
It would go back to standard methods, but I don't think we've really addressed that in the policy yet.
I just started seeing it past 2
Yeah,
years.
it was 1 year. They were good for 1 year.
Yeah,
To tell you the truth, we haven't addressed that one yet.
okay.
But we're going to try to keep the cost down for you people, so that's a good question. That is a good question. Try to remember that. These don't go bad overnight, so hopefully if you're purchasing a certified thermometer and it doesn't have an end date, maybe we can come up with a time period that you have to recheck it. If you take grab samples, usually like a pond system just takes your grab sample and sends it in. But there are times you might be requested to take a series of grab samples, then composite them. We need you to refrigerate each one of those grab samples until you composite it and then refrigerate it again, just to make sure that that temperature stays up. Otherwise, it's just going to hurt you because it's going to be higher BOD, etc. The chemical properties are going to change. So make sure you do that. Now, composite samples. This is kind of an issue I've been trying to get everybody to be aware of. Most of you folks come in the morning, right, and you take a composite sample. If you take a composite sample, or say 7 o'clock, 7:30, right, somewhere around there, and you check your flow meters, right? And the flow meters for the day before. So what date do you put on that composite sample? Anybody want to be brave here?
The day you sampled.
Pardon?
The day you sampled.
The day you took it out, you mean?
The day you took your sample.
So that it's the end of the cycle is not the sample date if you take it out in the morning. It's for the day before. So what is happening is they're doing a lot of studies right now. They're going to be using total mass discharge limits, TMDLs. So they want really accurate data, flow data. Well, say you lived in Duluth around the 20th of June, and you had the wrong date on that sample. You had a pretty high BOD sample the day after the flood, but you used the flow data for that 10 inches of rain from the day of the flood. What's it going to make it look like you had for a sample? Really, really high. Lots of pounds of loading. When you didn't really, it was all clear water. That's kind of that's a big example, but what you need to do is be aware of the sample date. Actually, in most states, you put the sample date on a composite sample, which is the previous day, which is the same as the flow data. Because when you get that sample result back, that commercial lab doesn't know. I've talked to some people with commercial labs that test in the state and say there's not even dates on the samples. You know, they just kind of fill in the blanks when they receive it. So stuff is way off. We need to know accurate mass loading when you calculate that per pounds. So you can write the date that it was collected because your holding time starts when that's collected. But you also need to write the sample date on there so that when you get your results back from that lab, you can calculate it with the right flow data. And we're kind of trying to get some type of policy put through. I don't know if that's going to happen, but we've been working on it for a while. But it's mainly common sense that you want to have it on the correct date. Say you go from midnight to midnight. It gets a little trickier if you have an automatic flow meter. But your sample should be on the date at the most hours. Say you took it at 2 o'clock in the afternoon, you picked up your composite sample. Then most of the hours are going to be on that day. If you take it in the morning, it's going to be the day before. As long as it coordinates with your flow data, that's all we worry about. Okay. Dissolved oxygen, we've had some questions about that too. Where people want to use other instruments and kits and things like that for dissolved oxygen. You can use a kit if it's approved by the EPA, because this is approved by the MPCA, because you are going to be putting this on your discharge monitoring report. So we'd like you to use dissolved oxygen meters, the field ones, and go out and take it in situ, take it right at that place, not run it into the building, because there's no holding time for dissolved oxygen. By the time you get it back in the building, it's going to change, especially for activated sludge, things like that. You can use Winkler. You can use Winkler, but when you go out and take that sample, you have to acidify it right there. Does anybody even do Winkler anymore? It's a pain in the butt. Anybody? Okay. All right. For dissolved oxygen, if you're not using an LDO probe, you need to calibrate it. And I've got all kinds of calibration charts back at the office if anybody wants them. You can find them online too. But you need to calibrate it to, most of them have barometric pressure built in and temperature, those two at a minimum. The LDO probes, if I were you, back to liability and lawyers again, I would at least refer to a chart, take and turn it on, have it do an AutoCal, refer to a chart, make sure it's in the ballpark, and sign off on it. Write down what it is and sign my name. It doesn't take that long. And it could save your butt sometime in the future, too. With LDO, like I said, just record the slope or check occasionally against a chart. Okay. pH meters. Almost everybody has to take a pH for their permit. And we're seeing a wide range of different types of pH meters around. The ones that we don't care a lot for are the ones that you just use one standard or one buffer because it doesn't tell you anything. A pH meter is just a voltmeter. You have to put in 3 standards. Standard methods now says 3 standards. And most of them call for a 4, a 7, or a 10. So they run by millivolts, like all voltmeters do. And you can see here the 4 is about 168 millivolts, which translates to a 4. The 7 is 4.6 millivolts, and the 10 is like around minus 160 millivolts. And it converts that to what the pH is. You could actually make your own pH meter if you want to, but this is how they work. And so it draws a line through those. So that if you take your pH and it's 5 or 6, it's going to say the millivolts to it and it'll read out exactly what that pH is. So one one buffer, or an old buffer that sat on the shelf open for a long, long time. That's another one of my pet peeves. That's not going to do you any good. I had a really good friend that he was just tighter than I don't know what. And he would use that same buffer. He had it in a beaker for like months. So I couldn't talk him into it. He didn't want to spend any money, and this stuff isn't expensive anyway. So I went up there and I said, okay, we're going to calibrate with your buffers that are sitting here, and then I'm going to put this 7 standard in and see what it really is. It was like 6.2. It was that far off. So I finally convinced him, I think. But they need to be buffers, and they make packs now where there's just, you just use it for one time. It's a single dose pack. Or just dump it out, and I think it's just a few dollars for a quart of buffer. So three buffers. The probes too, gel fill probes are nice. I used to buy them all the time, but they're only good for like a year and a half. And that's from the date of manufacture. And the more you use it, especially if it has grease on it, it's not going to work very well. If you sit it in something like a buffer, it's going to keep trying to take a pH, and you're going to use up all the gel right away. It won't last even that long. They're very nice though. They're almost indestructible. So the good ones, the ones that have the holes in them, it's got a little plug, they cost more, but they last a long time if you take care of them. You need to clean them out once in a while. You need to open up that plug when you're using it, plug it back up when you're not, otherwise they're going to get crystals in them. And if it does crystallize, you need to clean it out with distilled water and put more filling solution in. The very bottom of it has a hole too, it's a junction, and they get crudded up. So you just need to clean it. You can ask the company how they would recommend it. We used to sit it in some weak cleaning solution overnight. And then,
Those probes are supposed to be kept moist when not using. What do you recommend? Put them in water?
No, they make a storage solution that works really well, and it doesn't cost a lot. I would just set them overnight in that storage solution. Or the buffer that's recommended. It's usually a 7 that's recommended, but the storage solution, they will last longer. We did some side-by-sides on that. So ask your supplier about that. If people have a little bit of money, which doesn't happen too much anymore, I encourage people when they're getting a new pH meter, you get a pH ISE meter. ISE stands for Ion Selective Electrode. Anybody have one? What's so nice about these is you can buy probes that do just a ton of things that are accepted by the EPA. For instance, ammonia. I know Hutchinson does their ammonia using a probe method. You can use fluoride, you can do a fluoride, you can do chlorine using a probe method. So if your spectrophotometer dies and you want to get a new pH meter, kind of look into these. They cost more than a regular pH meter, but the size is coming down and the price is coming down on them. You just have to get the different probes. Spectrophotometers. Who here uses a spec? You guys all run chlorine and fluoride and things like that. There isn't really much to the smaller ones. There's a light, light source that goes through your cuvette, and then it goes through a little slit, and then like a prism. And then it's red on the other side. The transmittance is red. And the newer ones, it's electronic, and so they just interpret it into milligrams per liter or whatever you want. The big problem with spectrophotometers, well, there's two things. They get dirty inside. You need to clean them. And the cuvettes. Your testing is only as good as your reagent and how many fingerprints are on that cuvette. They're usually glass. And so what I tell people, use that same cuvette over and over and over because they get scratched. So if you're doing a blank with one, and then you're doing your tests, especially if you do duplicates to be certified, and there's a scratch on it, it's never going to come out right. And you need to set it in there. They usually have a line on one side. Excuse me. They usually have a line on one side. And set it in that instrument the same way each time. And the cuvettes aren't horribly expensive. When they get scratched up, throw them away and get a new one. The phosphorus, test and tube method gives you your own cuvettes. They have cuvettes that come with it. But you need to keep the fingerprints off of it. You need to keep dirt and oils and things like that off of it. For spectrophotometers, they can do a lot of things. Even if you're not a certified lab, I encourage people to get a handheld one just for process control. Because if you're going to have limits like phosphorus or ammonia nitrogen or nitrates or anything like that, that spectrophotometer can tell you where you're at, both in the influent and effluent. It all depends on what you buy for reagents. There's a lot of them out there on the market. It can do ammonia nitrogen, ortho, and total phosphorus. You don't need to digest it just to do an ortho. And then do a multiplication. It's usually like 75% of total phosphorus. So you can tell what your effluent is if you need to add more chemical or not. Fluoride, free chlorine in drinking water, total residual chlorine, all can be done with the spectrophotometer. You should be running a blank with anything that you do. And once in a while, at least, even if you're not certified, you need to do some standards too to see if you're in the ballpark. But that blank with spectrophotometers, if you add reagent to that blank and it turns a color, you know that something's wrong. You've got some contamination. That's usually just from having a dirty cuvette. But you need to find out. What people do is they do a blank and it'll be dark color and then they zero it. Well, what's that going to do? You're going to be so far off, it's pathetic. That's completely opposite of what you're really supposed to do when you're doing an analysis. That blank should be zero. If it's not zero, you don't zero the meter with the blank. That just tells you that there is some kind of a contamination issue with it. Cuvettes, like I said before, they're almost always glass because plastic scratches real easily. They can be square or round, but really start watching what you're doing with your cuvettes. Make sure that there aren't scratches or fingerprints on it when you're doing the analysis. And I would encourage people just to use one cuvette for the whole thing. Dump it out, clean it with distilled water, clean it out with the solution that you're going to use for the next one, if possible. Okay. The other bad thing about spectrophotometers is there's a lamp in there. And the lamps don't usually just go poof and burn out like our electric incandescent lights do. They burn out really slowly. And that's why people with certified labs have to do a series of standards to see where they're at. And you can see by doing that they kind of slowly change. But even if you're not a certified lab, keep an eye on that because that can change your results. You probably should have a frequent program of changing the lamps in your spectrophotometers, or you're not going to have very accurate results. And the other thing too, I'm just going to touch on a couple safety issues. Keep your MSDS sheets. Keep them forever. I don't know if you've got a place to file them, but any chemical that you use in a laboratory, they are required to supply you with an MSDS sheet. If not, call them and ask for it. And you need to keep it on hand. If someone does get sick and they say, hey, I think it's because I got a bath in this methyl ethyl death, then you can go back and look and see, okay, was this stuff really poisonous? Another liability issue. But you do have to have those on hand for everything, including what's not in the laboratory, paints and et cetera, other chemicals. And label. One of the labs that I worked in for a long time, there was a bunch of old guys that worked there, and they were close to retirement. And they used to come in the lab and have their break and smoke, and they'd take my beakers and pour their coffee in them and drink it out of my beakers. And those are beakers that I just use for influence, so. Most of them didn't live much past retirement, but I don't know if it had anything to do with it. So, label. If you're in the lab or not, label it, store it properly too. In my younger days, since I didn't have any chemistry, I made the mistake of putting, I think it was ammonia and acid in the same cupboard together. We had a nice snowfall in the lab during the night, so I learned the hard way on that one. But make sure everything is labeled. And, like I said before, we're from the government. We really are trying to help. Somebody had just talked to me about what's this program going to cost. Well, they had heard that taxpayers were very upset about it. This is going to be entirely self-funded. And yet, we're still going to save you money. We're hoping to get one position. In the meantime, Sandy and I and the rest of Sandy's unit are just kind of pitching in, trying to get this put together. We did not get one single bit of information to start with. So it's been quite the job. I can't believe that Sandy is still sane after all this. But we are going to try very, very hard to help people do this program and learn how to do a little bit of QA and QC and make it much easier than it has been in the past, and not such a mystery that it was in the past. So, any questions? Yeah.
Might be a young question. With the chain of custody, okay, I do my sample, I do my cooler, my chain of custody is in there.
Yep.
Postmaster signed off, and I get to that, then we take it. Okay, well then the truck comes and picks up the sample. I'm not there to see what's going on.
He doesn't touch the sample though.
Okay, that's what it is.
Yeah, it's people that really handle the sample. That question's come up quite a few times because when I was the director of an environmental lab, our people picked up the samples and they didn't want to sign off on it. But if it's in a cooler and it's sealed, you know that they're not gonna touch
I
it.
usually tell them it's poop water.
Yeah. They're not gonna drink poop water. That's a good question, Ben. Yeah.
Just to clarify on the composite sample, we start our sample in the morning. The next day we collect the sample in the morning. On the DMR, we write the BOD results on the day that we did the test. But then for kilograms per day, we use the previous day's flow.
You use the previous day's flow and the previous day and the day of the sample, which is the day before you picked it up, if you do it in the morning. That's right. the milligrams per liter that you would use. Yeah. I did a lot of consulting work, and I got called in to run a plant for an Indian tribe, and the EPA, they've been doing it wrong. They didn't know. I had to go back, I don't know how many years, and recalculate all of their loading. Because, it wasn't the right day, and the EPA wanted to know what it actually was.
Just to know that I've run into this, if you send samples out, I'm not going to name you into the lab, but you watch the date that comes back on your result, because you might find out that if I took it on, the sample was taken on the 4th, sent it, collected it on the 5th and sent it out. I've gotten results back that said the 5th, not the 4th.
Okay, yeah, you are responsible for that.
It does happen.
Yeah, I've talked to some of the commercial labs in Wisconsin and Minnesota, and they try to train their people, the difference between the sample date and the date they receive it and the date that it was collected. But sometimes things do slip through the cracks. Unfortunately, you're the one that's responsible. So keep track of it. When you fill out that form that goes with your samples, keep a copy so you know what was what. But it's become even more important these days with the TMDLs. Your permits, we're going to have some people from MPCA talking on how they calculate like your phosphorus limit, what they use for data. And they'll explain that this stuff is even more important than it was before because they want to know your mass loading. And when I worked for engineering firms, of course engineers always want to know what accurate loading is because they don't want to know how large to build that treatment plant. There were a couple places in Wisconsin, and when I was with Water, guys told me their secrets, and one of them told me that his coworker had cheated on the influent for years and years and years. Guess what? That plant was way under-designed when it was built. So, it can accidentally happen too. It does make a difference. Anything else? Okay. All right, thanks. I'll be around. And if anybody wants to see the rough draft of some of those Excel spreadsheets that we're working on, I've got those with me on my flash drive to